Well, hello guys. I wanted to share with you about this multifunctional tester of Joy IT, a producer, and it is most probably called the multifunction tester T7. And I used it for transistor measuring, but it can do so much more, and therefore I want to go with you through it, and then at the end, let's do some concrete testing with it. As you see right here on the product picture, it can measure BJT transistors, and I used it mainly for that. But then I noticed that it says here it is an LCR meter and it offers a wide range of functions at a low price. Indeed, I thought I bought this one for around 20 or around 20 euros. Um, and what it can really measure is written here. You can measure resistors, capacitors, inductors, thyristors, triacs, diodes and double diodes, set diodes, field effect transistors, bipolar transistors, and it is also an infrared decoder where you can measure the pattern that comes out, for example, of your TV control, and it supports in the infrared protocol um, domain the NEC protocol, which is used by many manufacturers, as they say here. Um, this has a built-in 3.7 volts accumulator with 350 milliampere hours, and I really think that's a little too small because when you leave it on the bench, and even if it's turned off for around a week or two, then it completely unloads itself and is empty. So I will be doing another video where I try to replace this built-in accumulator through a newly bought one for around €7. But now that's another video. Let's do now the functions here further. So capacitance in the ranges of 25 picofarad to 100 millifarad, resistances from um, 0.01 ohm, so sub 1 ohm it can measure, and up to 50 mega ohm, which is really, I think, all you can ask for. Then inductances from 10 microhenry to 20 henry. Batteries it can measure, never tried that, maybe we'll do it in this video, from 0.1 volt to 4.5 volt. They explicitly say that don't go over 4.5 volt because you could destroy some internal components when you go over 4.5 volt here. So no 9 volt battery measurement, please, here. Then Z diodes, diodes with a forward voltage of lesser than 4.5 volts. So this will cover all the standard diodes, most probably, and thyristors and triacs. So that's the layout of it. So you just turn on the yellow button, you press it, and if you plugged in your device to these slots here, then it immediately will show you the test results. And you can recharge it via a standard micro USB port, which some still have for their smartphones. As you know, USB runs on 5 volts, so you can take anything off the shelf from your local electronics market and just plug any USB cable in here with a standard charger adapter, and it shows you here with this LED. Once it is green in the loading process, if first it's red, then it gets green, and then it's fully charged again. There's also some initial measuring, calibration mode, and here's how to measure the things. They also deliver 2 of these cables with these nice yeah, kind of alligator snaps at the end. And yeah, and then they go into what you can measure with it and what the display will be like. It's a diode here with 716 millivolts forward voltage. Even it shows you the leakage current and the capacity of the diode additionally. So very sophisticated, your standard resistor measurements. So basically you don't need a voltmeter anymore, big clunky voltmeter, because this device is really small. It's around, they wrote it up there, around 10 centimeters by 9 centimeters somewhat, and 5 centimeters high around. It's very compact. And capacitors. Okay, you have to discharge capacitors, because else if the capacitors are loaded with high voltages, you can destroy the device. That's kind of clear. Yeah, and then all the kinds of transistors, which I mainly used it for. Here again, when you measure batteries, it's set at no more than 4.5 volts. And this nice infrared decoder, where you can measure the data patterns that come out of your, for example, TV control. Yeah, and with that, let's go into some measurements with this thing.
So, and here we are. So I picked out 4 random components of my arsenal. So we have here a light emitting diode, a LED. Here's some 3-pin component, which I really don't know what it is. I could read it, but we'll find out that this device can also help us in finding out what it is really. And here's some random type of capacitor. I don't know how much farad this has. And here a resistor. And so let's start the process. I don't need to care about what is written on them, because I can test all this. So perhaps let's start with this light emitting diode, this red one. So usually we're in the range of around 2 volts to make a red LED light. But let's see. We just plug it here into the top row. Just have to make sure that you always connect to different numbers. So the foots don't have to stick in the 1 and the 1 here, because then you essentially would have the same pin on both foots. You just have to make sure that the numbers are different where you connect the foot. So I'll do it in slot 1 and slot 3. So in here. And then you can, let's do it a little bit. So now you can sort of lock the thing with this lever here, and then you just press the yellow button for start. Yes, a little bit longer perhaps. And then you see it says my forward voltage on this red diode to light up, it's 1.91 volt, so around 2 volts like we said. And there is a capacity of 0 picofarad on this LED. Very nice. So let's do another one. Let's pick this 3-pin component. Really don't care about reading it, just locking it here in the slots 1, 2, 3. So different numbers for the 3 different legs. Let's start the measurement. And it tells us it is a BJT transistor of the NPN type. And we have HFE of 496, which means this BJT transistor scales up current by 496. Oh, well, let's do it again. For 489 it says a voltage of base to emitter of 658 millivolts. So the base emitter diode is 658 millivolts, and a collector current of 2.6 milliampere at the moment. Okay, nice. Then this was a BJT transistor, nice to know. Then let's do this capacitor. This blue one connected to pin 1 and 3, really doesn't matter. Lock it, measure again. And we have an 81.04 nanofarad capacitor. most probably nominal 100 nanofarad capacitor, but you see it's concretely 81 in practical terms. And at last, this resistor, which has these legs spread out quite far, and I connect them to over the whole thing here, slot 1 to slot 1 here to slot 2 there, lock it, measure it, and it says it is a 97.9 ohm resistor. And if we look at the rings, can that really be? So we see it's brown, black, black, black. So brown, black, black means 100, so 100 with a multiplier of black, which means 1. So we have really a 100 ohm resistor here. And as we saw, this device really measures these things quite reliable. So that's it. Thank you, and see you in the next video.